Hi, tonight we're going to do hard cider. And if you don't have any familiarity with brewing beverages, beer, wine, cider, it's probably the simplest to get started with because of the availability of the materials. The very simplest fermentation you can do, however, is what's called a sugar wash. You take sugar, add it to water, add a little bit of yeast. A week later, you have alcohol. Now you might think because you're using pure sucrose that there wouldn't be any flavor, but there is. The yeast, in processing the sugar, produces some complex chemicals and will add a detectable flavor to the sugar wash. And this is important because when you are fermenting a beverage that is as light or delicate as, say, a champagne or a cider, the yeast will contribute a significant amount to the final product. So you want to use a good yeast. Now, for simplicity's sake, the easiest thing might simply to be get some bread yeast. You can get this at the store. This actually works pretty well. You can make a good cider with bread yeast. But if you want to up your game a little bit, you might use what's called a daddy yeast, or distiller's active dry yeast, DADY. One of the advantages is because it's available in bulk, this is actually less expensive per gram than the little packages of bread yeast. It also will survive a little bit higher final concentration of alcohol in your beverage. That's not going to be a problem with the cider. But it also, in my opinion, adds a little bit more breadth to the flavor. I think it's a little bit better choice than the bread yeast if you want to do that. Now, if you want to up your game even a little bit further, you can use a product Y yeast. This is actually a liquid yeast. You have to keep it in the refrigerator before you use it. And it's specifically designed to ferment mead, cider, sake, wine, and will produce more depth of flavor and a broad palette of flavors than will the daddy yeast. So this is a great way to upgrade. You might want to go to an actual cider-specific yeast. Cider House makes a yeast that's designed specifically to produce cider. I've used this and it's actually very good. It produces an excellent cider, has a lot of depth of flavor. But my favorite is from a company called Fermentis. Out of Belgium, this company actually manufactures a variety of yeasts specific to cider itself. They produce one yeast that produces a very tart, very sharp, dry cider that's very similar to a brut champagne. And on the other extreme, they produce a yeast that will produce a very sweet and aromatic type of cider. My favorite, though, is this AB1. This is sort of the mama bear. It's kind of the balance of both extremes and is my favorite yeast for producing cider. And it's what we're going to use tonight when we make the hard cider. Now, the next thing is the juice. Convenience-wise, you might just go to the grocery store and pick up a bottle of apple juice, Mott's apple juice, for example. This isn't horrible, but it's close. I don't know what kind of apples they use in here. I'm not even sure they do. And it doesn't have a lot of breadth of flavor. It's a fairly simplistic type of juice. In addition, they add a fair amount of vitamin C or ascorbic acid that acts as a preservative. So they can keep this in a bottle at room temperature on a shelf for years. I think a much better choice, if you do this at the right time of the year, is to get fresh cider right from the orchard. We live in New England, and in the fall we get lots of apples. And this particular orchard will mix about 6 different varieties of apples together to produce their cider. It has a lot of flavor. It's very flavorful. It's very aromatic. And when you consider it costs just the same as the apple juice, it's a much better choice. Now, the second thing that you may wonder about is the container, if you've never done this before. A lot of people will use what are called carboys. These are these narrow-necked vessels made either out of plastic or glass. They hold about 5 gallons of liquid, and they're the things that you would normally invert in a water cooler. I hate them. First of all, they're very difficult to clean. Because of the narrow neck, you have to get special brushes to get inside of them to clean them out. They don't have any handles, and the glass vessel, when it gets wet, gets very slippery. And when you load it up with a bunch of liquid, it gets slippery and heavy. A much better choice, a lot easier to work with, is a stainless steel cooking pot, especially the kind that come with a glass lid like this, that allow you to look inside and see what's going on without breaking the seal and without actually going into the vessel. These have nice handles, they're extremely easy to clean, and in addition to that, if you're going to be doing any kind of a fermentation that involves heating, like say boiling a wort, you can use the same container both for the boiling and the fermentation. It saves equipment, it minimizes cleaning, and it also minimizes the potential to get cross-contamination as you're moving between vessel and vessel. Now this particular cider is raw, fresh cider. It is not pasteurized. And if you wanted to, you could boil this to remove any kind of wild yeasts or bacteria. I find that when you do that, the final result tends to be a little bland, a little flat. I think the heating process damages some of the delicate chemicals that provide the flavor in the cider, so I don't do it. And because we are going to be using an overwhelming quantity of very healthy yeast, we're going to very quickly overwhelm any of the natural biologicals that may be in these containers. And in my experience, after having done this for many years, I've never had a failure or a spoilage because I use the fresh cider. But if you want to boil it, it's up to you. Now the next thing is cleaning. When you clean, you start out with soap and water and you get all of the visible debris. You make this as clean as you can. But another step that I like to use is a disinfecting step. I use this material called Star San. This is a disinfectant that operates at a 1 to 1,000 dilution. So if you're making up a liter of this material in warm water, you'd use 1 milliliter in 1 liter of water. If you were going to use their little gauge here at 1/4 of an ounce, you would add 5 gallons of water. And the trick is, you pour the stuff into the container, you add the appropriate amount of water, take your thumbs, put it over the top of the container, and shake it up. Just get it wet on every surface. Then, if you've got any kind of equipment that you're going to use, put that in there, rinse that out, and get that nice and wet too. Then, what you do is you simply take all of the remaining liquid and throw it out. But don't dry it, don't rinse it. Whatever is left behind, the minuscule amount of the disinfectant, will not inhibit the yeast growth, but you'll start out with very sterile, very clean equipment, in addition to the spoon that's sitting on the table in a little drop of the material. It works really well. So with that in mind, now what we're going to do is we're going to move over and we're going to look at the cider itself. Now this container here is a 3-gallon vessel, and we have 2 gallons of cider, so 8 liters, 12 liters. That's a good ratio. You want to fill the pot up no more than about 2/3 full so that you have a good gap above there for any kind of foaming that might occur. So the first thing that we're going to do is we're going to weigh this cider. I'll explain why in just a sec. Let me turn on my little scale. Let's see if it's buggy today. No, it's working. And we get 3.95 kilograms, or 3,950 grams. Trust me, the empty container weighs about 100 grams. So we have a net here of 3,850 grams. We're going to measure the other one now. They're probably pretty similar. 3,900, so we subtract 100 from that, 3,800. So we have a total of 7,650 grams of cider. The next thing we're going to do is measure the sugar content in here. So let's get this out of the way so we got more room. And the way we're going to do that is we're going to take this cylinder here and we're going to weigh it empty. We're going to tear it out at 0 grams. Now what we're going to do is we're going to add some cider to this. And the trick here is I'm going to add a little bit of cider from each container just in case these come from a separate press and they have a different amount of sugar in them. So I'll add about half of the container with this one and then half with the other one. And hopefully I don't make too much of a mess. Now we're going to weigh this. And we get a net of about 142 grams. That's how much liquid we have in here. The way we're going to estimate the sugar is we're going to use a calibrated float called a hydrometer. Now, there's another way to do this using a visible light refractometer that a lot of brewers use. And it works. I have one. I like it. But this is a little bit more obvious in terms of the physics, and so we're going to use the float. It works very well. The way it works is that the density of the liquid determines how deeply this will float in the liquid. The denser the liquid, the more shallowly this will float in the liquid. In addition, you'll see this table that's listed along the top of the float, the part that's going to extend out of the liquid. And we're going to read the numbers off here to determine how much sugar we have. So if we put this into the cylinder and we let this settle in, what we're going to do is measure the number, which, if I can turn this around so the camera can see it, shows that this is floating at about, 34. See, that's a 40, that's a 30, so call this about maybe 36, 38. Okay, that stands for 1.038 on a scale where water, pure water, would be 1.000. Now, that's important because if you take this out, and I'm going to rinse this off a little bit so the camera can show this table again, and you look at the numbers that we were seeing in the float, you see 20, 30, 40. If you turn this around like this, you can see corresponding here at the 40 is a number 5%, or a little bit below there. 0%, 2, 3, 4, 5. What that means is that is the amount of alcohol you will get if all of the sugar at that density of 1.038 or so were converted into alcohol. So about 4.5 to 5%. It's a little bit thin because typically you want to have something around 1.060 or a little better in order to get a decent alcohol content. Now, I'm generally not an advocate for adding sugar to any of my fermentations simply because the idea is that I want flavor. And if I want to get a certain amount of sugar, I'll just add more fruit, or I'll add more malted barley, or I'll add the product that gives me the flavor as well as the sugar. But in this case, I'm kind of trapped. This is all I have to work with. So we're going to add some additional sugar to this to bring the density up. So what I'm going to do is get a little bit of this table sugar. And with the scale at 141, let's go ahead and enrich this a little bit. And let's add maybe around 5 grams or so. Okay, so we got about 5 grams of sugar, like that. Now we're going to mix this up in a very scientific way. We're just going to dissolve that sugar in the cider, and then we're going to use the float again to measure what kind of density change we got. So let's see where we get when we add our little hydrometer here. Now remember, we are just a little below 40, so we're going to look to see where we get now. We're a little bit below 50. So we're about halfway there. So what we're going to do is we would add 5 more grams of sugar, see if we can get up to where we're looking for. So get my little spoon and add about 5 more grams of sugar. We're at 146. A little bit more than that. About 151. Let's mix this up, or dissolve the sugar, I should say. And I do this slowly to minimize the amount of bubbles. It makes it a lot easier to read the hydrometer when you're not doing it in a bunch of foam. So don't get too excited when you do the tipping stir. And then we'll go ahead and we'll put this back in here, and we'll see if we've gotten any closer to where we want to be. Remember, we're looking for about 1060. We're at about 1061. Excellent. So we needed to add 10 grams of sugar in order to bring about 140 grams up to the right density. We have about 7,600 grams here. So we need to use probably around 55 or so times as much sugar to get us up to the right density here. 55 times 140, we're about 7,500 grams. It's close enough. So if we use 10 grams of sugar and we need 55 times as much, we need 550 grams of sugar. So let's go ahead. I've contaminated this with my hand, so we're just going to throw this out. We don't need this anymore. And we're going to add the cider to the pot. Now we're going to measure out 550 grams of sugar. Let's go ahead and get rid of this and rid of this. Let's get a bigger cup like this. We'll tear this out at 0. And let's see if we can get about 550 grams in here. I don't know if it'll fit. We'll find out. We may have to do this in 2 batches. We'll see. Let's call that 400. And so we're going to have to add another 150. There we go, 150. So let's go ahead and put that in here like this. And let's use our spoon to mix this up a little bit. We don't have to get crazy because this dissolves pretty easily. Now the next step is yeast nutrient. Now what this is diammonium phosphate and synthetic urea. It's a source of phosphorus and nitrogen. Now there may be enough phosphorus and nitrogen in the cider itself, but this isn't going to hurt and acts as sort of a vitamin to make the environment super favorable for the yeast. And you add this at 1 gram per liter. So we have about 7.5 liters. We want about 7.5 grams of this yeast nutrient. So I'm going to use my higher resolution scale here for doing that. Put a little cup on here. Zero it up. Let's see if we can get about 7.5 grams. And you don't have to get too crazy about this because you might not even need it, but it's not going to hurt anything. Oh, well, that is too much. Let's see if we can fix that. Okay. Stuff's cheap. You ever heard the old theory, better is the enemy of good? That was an example of it. So let's go ahead and add the yeast nutrient. Go ahead and mix this up again. All right. Now the yeast. Now in theory, what you can do is you can simply pitch the yeast. You can take the yeast, open the packet, and just sprinkle it on the top and you're done. But what I'm going to demonstrate is what's called proofing the yeast, or another way of thinking of it is proving with a V. We're going to make sure that we've got a really good vital pack of yeast before we commit it to all the liquid that we have in here. And the way we're going to do that is we're going to take a small cup like this and we're going to add a small quantity of the liquid that we have in here right now. Don't need much, just a little bit. And then I'm going to add a little bit of distilled water to this. Simple purpose for adding the water is just to make this a little more dilute, maybe a little gentler on the yeast as we're waking it up. And then what we're going to do is pitch the yeast into this yeast starter mixture here. Now the quantity of yeast in here is 5 grams. This would be enough to do as many as 5 gallons or 20 liters. But because the yeast is going to be doubling in its number very quickly, like the old emperor and the chessboard, double, 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 it really doesn't matter. As long as you add a reasonably similar amount of yeast, you're going to have plenty. So we're just going to pitch this on the top of this. Then I'm going to give a little swirl here. And we're going to give this about 15 or 20 minutes to proof and to demonstrate that we've got a good viable packet of yeast here. So put the lid on here to keep the bugs and the flies out, and I'll see you in just a bit. All right, this is looking pretty good. It's starting to foam up, it's thickening, getting a little creamy. You can smell that bready smell of the yeast. This is good yeast. So we're going to go ahead and we're going to add this to the mixture. And we'll rinse a little bit extra out just to make sure we get all of that goodness in there. And that's it. Now, we're going to cover this up. And because this is a boiling pot, it has a little bit of a vapor vent here. And I'm going to put a little piece of packing tape over here just to seal this up. And for those of you who are concerned about the seal quality of this, it's excellent because the lid sits on a flange inside of the pot. And because of the process that occurs in here, producing a little bit of humidity, you get a little bit of vapor that settles down in here into a little liquid and acts as sort of a water seal. And remember, there's always a little bit of positive pressure of the carbon dioxide as it's being generated, so flow is always coming out of here. Never had a problem with any kind of contamination with this vessel. It works great. Now you got to wait about a week to 2 weeks. The question is, when exactly are you done? And there's 3 ways to determine that. One way is to simply take your hydrometer and every few days take some of the material out and measure the specific gravity. And as the dense sugar water is being converted into less dense alcohol water, the hydrometer will sink deeper and deeper and deeper into the cylinder. When that process stops, no matter what number you get, when it stops settling, you've stopped producing any additional alcohol and you're done. Problem with that though is it can get a little messy, and in addition you're getting into the container multiple times, potential for contamination. Another method, which is just about as good, is simply to take the lid up occasionally and smell it. Just take a little whiff of the gas inside. When you do so, you'll get a very sharp tang inside of your nose because the carbon dioxide, when it gets into your nose and touches the mucous membranes, the moist mucous membranes in your nose, it's converted into carbonic acid, like citric acid. It stings, it burns. It's a little bit like putting your nose over a fresh can of ginger ale. It's tart, it's tangy. And as the CO2 stops being produced at the end of the cycle and it begins to dissipate, when you take a sniff inside of there, it'll get weaker and eventually it'll disappear and you're done. But probably the simplest method of all is simply to look in the container. After about 2 days, the material will begin to produce a lot of carbon dioxide and you'll get foam on the top. And that foam looks a lot like the foam on a Guinness Stout. It's a brownish type of foam and you get little bubbles in it. That foam will continue as long as the yeast continues to produce carbon dioxide and alcohol. When the yeast stops producing the carbon dioxide, it begins to die and settle down to the bottom of the container. The foam will dissipate, it will disappear, and what you'll end up with will look something like this. This has been going for about 11 days. And if you take a look inside here, you can see that you have a layer of amber liquid in here. It smells fantastic, and this is the finished hard cider. The problem is you can't simply take this big pot and start pouring it into bottles or into glasses because you have all of that dross that's on the bottom of the container, the dead yeast. So you want to get that out, the liquid out, but leave that material behind. And the way you do that is this. We're going to take a little support here to elevate this a bit, and then I'm going to lift up this container, put it here like this, and then we're going to siphon it out. Now, for siphoning, you could simply use your mouth and a tube. You just put the siphon inside of here, develop a little bit of a column of liquid, and drain it into the cylinder. However, I've got this little couple dollar hand siphon, so maybe it looks a little bit better on camera. But in any case, the trick here is that you want to pre-measure the length of the tubing that you're going to insert in here. You don't want it so long that it's sitting on the bottom and sucking the yeast out of here, and you don't want it so short that you don't continuously get a siphon. So measuring it on the side of the containers so that you're a couple of centimeters or maybe an inch or so off of the bottom, you're going to insert this in here like this, below the surface, and then you're going to start a siphon action here. And we'll start this going. And we'll start this draining. Now you kind of want to keep an eye on what's going on in there just to make sure your tube is staying in a good position, and it's a good idea to rest your hand on the vessel just so that you don't make a mistake, forget what you're doing, and you end up with this stuff pouring onto your shoe. And then once this fills up, you're going to want to break the siphon, but you want to do it in the right way. You don't want to break the siphon by lifting this part out of the vessel. You're going to end up leaving a lot of liquid in the tube. When you get close to the level that you're going to want to end up using, what you do is you break the siphon at this end here and allow the remaining liquid to drain into the vessel. So a little before you're ready to actually stop, you go ahead and you lift this up, break the siphon, and let the remaining liquid drain into the cylinder. That minimizes the amount of mess you make when you take the siphon out. Now, this is perfectly fine to put in a vessel and to drink. It's great. The only problem is, aesthetically, it's not as good as you can do. Because this is a little cloudy, there are still some very, very small suspended particles in here, and it would be nice to make this nice and clear. Now, there are three ways you can do that. One is, if you have one, you can use a centrifuge, and you can simply spin it down. But not everybody has a centrifuge. And in any case, even a high-capacity centrifuge will only handle about 300 milliliters in a go, so it would take a lot of cycles. Another alternative is to use a vacuum flask. Let me bring this around here. Placing either an aspirator or a vacuum pump on a heavy-duty flask like this, and placing a funnel that has holes in the bottom of it. You place this in here and you use the vacuum to draw the liquid down through some filter paper and remove the particles above here. This isn't particularly convenient because the particles in here are the scale of microns or nanometers. They're very small. And any kind of filter that is sufficiently aggressive enough to pull that stuff out of here will very quickly get plugged up by the particles. And so you're going to go through a lot of filter papers to get this to filter out. There's a much more elegant and easier method to do this, and that's called agglomerative filtering. And the way you do that is with kitty litter, or in this case, bentonite clay, food grade bentonite. It's the same stuff. And if I open up this container, I'll show you. What you have here looks like gravel. It's a mineral clay. And this material, when you suspend it in water, will create lots of very tiny little particles. So you take a ratio of 200 milliliters of water and 10 grams of the bentonite clay, and you pour it into the water to get it suspended. Now, if you take a little spoon over here and you mix this up, what you're going to find is that very quickly on, you're going to get sort of a matzo ball in here. This stuff doesn't break up very easily. Now, if you're patient and you mix this every couple of minutes for about 6 hours, you're going to end up getting a nice suspension. But a far easier way to do this is simply put this on a hot plate or add the bentonite and water to a pot and put it on a stove and boil it for about 20 minutes. The action of the boiling and the increased thermal turbulence will actually get this to form a very nice suspension with very little work. And when you're done, you're going to end up with this. This is a bentonite mud. And this stuff is good for years. You can make this up ahead of time. It doesn't settle. It doesn't spoil. It has a great smell. It smells like the inside of a very clean limestone cave, a very mineral type of smell. Now, the way you're going to use this is you're going to take this material and you're going to add 30-to-1 ratio to the liquid inside of your cylinder here. So right now we've got a little beaker that will hold as much as 50 milliliters. We've got about 1,000, so we're going to try to put about 30 ml in here. And we're going to simply add this to the cylinder, just like that. Then what we're going to do is we're going to put a little plastic lid on this, or a little plastic stretch cloth, cover the top of this like this, and then with a rubber band, so that this seals up a little better, we're going to go ahead and invert this a couple of times in order to mix in the bentonite. Now there's a little CO2 in here, so we may get a little bit of leakage as the pressure tries to bulge the top of the lid here, but it doesn't matter. We've blended this in. Now the result, you can see, looks worse than ever. But just wait. Give it a little bit of time. All right, so we've had about a half hour, and you can see what's happening here. We're getting a clear liquid, and then we're getting the debris that's slowly settling down here. The reason this happens is because when you take the bentonite and you suspend it in the water, you form billions of tiny little particles, but the particles have a very high surface charge, electrostatic surface charge. And as they float in the liquid, they're small, but they attract the even smaller particles that create the cloudiness in the cider. And as those small particles approach the bentonite, the electrostatic attraction causes them to agglomerate and form ever larger and larger particles. The thermal vibrations, or the Brownian motion that keeps the particles suspended in the cider, is not able to overcome these much more massive particles, and they begin to settle down toward the bottom of the container. So you can see within a short period of time of about a half hour how much clearer this is getting. And it will even go a little bit better if you put this in a refrigerator, because you will decrease the thermal vibrations or the turbulence a tiny little bit extra. If you wait even longer, for example, overnight, this is what you end up with. A crystal clear liquid here and a small pellet of the dross, or the particles that had originally been floating in here. And if you take the top off of this and we put this up here, we can then use our siphon to fill a little champagne glass. And what we get is a beautiful, clear, amber liquid. It looks like champagne or sparkling cider. It smells of apples. But there's also a flavor of pears and maybe even cherries. This is a very elegant drink. It does not look like you made this in your garage. It tastes very pricey. It's excellent and it's easy to do. But we're going to kick this up another notch. Now, I've always been intrigued by magicians and flair bartenders because they do such an excellent job of demonstrating physics and chemistry principles. So one of the things that you can do to liven this up a little bit, especially if you want to impress your friends and family, is you can take a small quantity of dry ice and add this into the container. Now what this does, beside giving you a little bit of a reminder of Macbeth, is that this small quantity, about 10 to 1 or less by weight, will completely evaporate. All of the dry ice will be gone in a couple of minutes, but it will chill the glass down to just above freezing, which is kind of interesting, and it will do it right in front of your audience. But it will also carbonate the liquid, and that carbonation adds a little bit of extra zing to the drink, just like the difference between a flat cola and a carbonated cola. It doesn't change the flavor, it just makes it a little bit more spicy, a little bit more tangy, and you gain a little bit of extra, I don't know, pizzazz to your drink. But we can actually kick this up another notch. This is vitamin B2, or riboflavin. It is the most fluorescent of all of the vitamins. And if we add a little bit of this to the container, or the cider, you can see what this will do when I put this in. This will make it glow in the dark. So if you're going to do something like a Halloween party and you want to impress your friends with cold carbonated beverage, or a beverage that has that sort of black light and Halloween look, doesn't change the flavor, but it makes it a little spookier. So hopefully you found this both entertaining as well as potentially useful. These are excellent beverages and they're very easy to make. And if you like the kind of stuff that we do on this channel, appreciate it if you watch, because the kind of stuff that we're doing here is just a sample of the kind of stuff that we put up. And I would love it if you'd subscribe, because that really helps the channel to grow and it gives us a lot of positive feedback for what we're doing. So I'll wish you a good evening, happy brewing, Vaše zdrowie.